My name is Ian Ferguson. I am the Dean of the Southern Polytechnic College of Engineering and Engineering Technology. My broad-based research interests focus on building interdisciplinary teams of faculty and students to use compound semiconductor materials and devices for applications in the areas of sensors, illumination, energy harvesting, and spintronics. A compound semiconductor material, unlike silicon, can strongly absorb and/or emit light, which makes it useful for optoelectronic devices. For me, the sense of success comes from the ability to work with multiple people in multiple different locations with shared goals to achieve outcomes for a specific societal impact. People get too focused on what they think is a particular research expertise rather than the notion that even in research, it's about lifelong learning. I tell people I have a research expertise, but my expertise is research. That is the ability to move in and through new problems over time. That is important. Throughout my academic career, I have operated under the philosophy that lifetime learning is paramount when tackling problems that are increasingly complex, requiring both an analytic mindset and a creative spirit. I wanted to be a professor since I was 12, even though I didn't know what that entailed at the time. Now I understand it's about the journey. I have purposely taken an interdisciplinary approach to research by working at the boundaries of academia and industry, and this matches well to this institution. The research for my master's degree in optoelectronics was completed within industry, and my PhD, funded by a CASE award, allowed me to complete the research between academia and industry. My PhD and postdoc in the United Kingdom focused on molecular beam epitaxy. This is a materials growth technique for the production of very, very thin single crystals of semiconductor materials. MBE is widely considered to be one of the fundamental tools for the development of nanotechnologies and the resulting quantum devices. My research approach is focused on innovations in device functionality through materials research. What does this mean? We bring new functionalities into the device through its material properties rather than producing more complicated devices in established materials. These compound semiconductor materials, such as gallium nitride and zinc oxide, have led to the development of new devices ranging from detector sensors to light-emitting diodes and solar cells. When I moved to the US in the early 1990s, my focus increasingly changed to applied research, which is more prevalent in the US compared to Europe. I started to investigate wide bandgap materials for detectors and emitters. At Northwestern University, I completed the construction of a large clean room and also managed a multi-user crystal growth facility. Wide bandgap semiconductors to permit devices that operate at much higher voltages, frequencies, and temperature compared to conventional silicon devices. I then transitioned to industry and MCOR Corporation as the Director of Research, having developed an interest in solid-state lighting, i.e. the use of LEDs in lighting applications. I contributed to the development of Group 3 nitride growth technologies, and this was funded by various small business administration grants, resulting in a commercial reactor technology that's now part of a multi-billion-dollar-a-year industry. The work of this team was recognized by a Small Business Administration Tibbetts Award for contributions to the SBIR program, and this was received at the White House. I also founded various international conferences on solid-state lighting around that time. I finally arrived in Georgia Tech in 2001, where I established a larger research group that included undergraduate and graduate students, postdoctoral researchers, and visiting fellows. We focused on the basic, the applied, and more commercial aspects of research depending on the individual's interests. We studied a growth technique called molecular organic chemical vapor deposition to produce compound semiconductor materials. It's a process for growing very thin crystalline layers to create complex semiconductor structures. The work continued to focus on numerous applications that gave the students to find the best fit to their interests in the areas of sensors, illumination, next generation solar, dilute magnetic semiconductor materials, and anthrax and/or nuclear detection. In the last decade, while at the University of North Carolina in Charlotte and Missouri University of Science and Technology, my work has continued to focus on energy harvesting, which refers to the process of capturing and converting energy of different types, heat, light, and otherwise, from the surroundings to electricity. This work included new research using atomic layer deposition, a thin film deposition technique based on the sequential pulsing of gases into a reactor that allowed single layers of atoms to form that could then be used to synthesize crystalline structures that did not exist. I joined KSU in 2019 at a time of rapid growth and innovation. The Southern Polytechnic College of Engineering and Engineering Technology is rich with history and is well respected across the region. We are thrilled to usher in a new era of engineering at KSU with the addition of a Master of Science in Intelligent Robotic Systems and a PhD in Interdisciplinary Engineering now being offered. These degrees will further emphasize our status as a leader in engineering and generate tremendous opportunities for our students moving forward. As an experimentalist, I've been able to employ a more general creative process. It doesn't matter where you started in your educational journey, but it matters what you do. Therefore, my approach to engineering education focuses on understanding how the student's skill set maps into an engineering discipline rather than training them to be in engineering. We have the ability to support research in our many state-of-the-art laboratories and facilities in the college. However, this research is driven by the interest of the individual faculty members, and the college conducts a wide range of research projects annually. My current research interests at KSU has moved towards controlling the spin of the electron in semiconductor materials and devices at room temperature within an emerging field called spintronics. This has applications in new information processing technologies such as quantum computing and neuromorphic devices. I've begun this work with faculty across different disciplines at KSU, in addition to maintaining other external relationships to enable this research. With all these exciting initiatives, I have a deep appreciation for the efforts of our talented faculty and diverse student body at KSU as we solidify our role as Georgia's engineering college. The creative process in science and engineering is very similar to that of the arts, so I also write poetry. There's a naked in my heart, a desire to create that reaches out towards a fragmented image that overlaps with this present time, that when its grasp is like walking into the mist that slowly disappears around you as the sun works to bring life to this day, adding color to grey and words to this poem and this research journey.